The rate of change of, take the statement, the rate of change of substance having let us say having mass m at any time t is proportional to total amount of substance, that is dm by dt is proportional to m. The rate of change of substance, you may assume, for example, population. The rate of change of population, if m amount of population is there, is proportional to total number of peoples or total number of populations. So dm by dt is proportional to m. Now to remove this proportional sign, add the constant of proportionality. If we assume m as the constant of proportionality, then it is k times m. So this positive sign indicates if we increase time, then n is also increased. So if m is increased with respect to time, then take the positive sign. And when we take a positive sign, then it is the law of growth, is it? But in few cases, if the population decrease when we increase time, then it comes under the decay. Okay, so when it comes under the decay, then we use the negative sign to remove the constant of proportionality. Okay, so as a note, you just write when the rate of substance decreases or decompose, you may assume anything, decreases or decompose with respect to t, then dm by dt is equal to minus k times m. When the rate of substance decreases with respect to time t, then dm by dt is equal to minus km. That is the law of decaying. This is nothing but the law of decay. So the decomposition comes under the decay and increase or growth comes under the law of growth. So we use these two statements, and how we find the solution of this particular differential equation. So by using variable separable form, now we have two variables here, m as first variable and t as second variable. So by separating the variables, so how we separate the variables? This m in LHS side and t in RHS side. So by separating the variables, here your differential equation looks like dm by m is equal to k times dt. And then by using the initial conditions given in particular result, we find here total amount of substance with respect to time, or any time with respect to the total amount of substance. So whenever growth is mentioned, apply first rule, and whenever decay is mentioned or whenever decomposition or decrease is mentioned, apply the second step. dm by dt is equal to km, dm by dt is equal to minus k. So let's take few examples. Take the first. If the population the population of India, if the population of India doubles in if the populations of India doubles in 50 years. इंडिया का पॉपुलेशन 50 years में क्या हो रहा है, डबल हो रहा है. So what is the initial population? We may assume initial populations as any value, or we may assume it as some m. Then it will be doubles in 50 years. 50 years में क्या हो रहा हो, 2 times initial populations हो रहा है. In how many years? In how many years will it triple, और ट्रिपल भी बोल सकते हैं आप, ट्रिपल और ट्रिपल. In how many years will it triple or triple? Under the assumption that, actually second statement is no need to write, but you just add under the assumption that the rate of population or rate of growth is proportional to the rate of population or rate of growth is proportional to number of inhabitants. Is proportional to number of inhabitants. Okay, so here we use growth because in 50 years it will be triples or it will be doubles, and here we find total number of years when it will be triples or 3 times. So let us assume at t is equal to 0, m is equal to m0. That is the population of India. Initial population is m0. Okay. So assume the initial population as m0 because we don't know the exact value. कितनी है पता नहीं है भाई. Exact count हमारे पास नहीं है. इसलिए हमने क्या assume किया है, m0 assume किया है. But after 50 years, as we know, it will be doubles. 50 years में वो क्या हो रहा है, doubles हो रहा है. So m is equal to 2 times m0, and find the number of years when it will be triples 3 times. So find t. अभी क्या फाइंड करना है हमें, टोटल नंबर ऑफ इयर्स फाइंड करने हैं. जब हमारे पास पॉपुलेशन कितना हो जाएगा, बढ़ेगा, वो ट्रिपल होगा 3 टाइम्स बढ़ेगा. ओके, सो बाय लॉ ऑफ ग्रोथ dm by dt is equal to km, and by variable separable form dm by m is equal to k times dt. By variable separable form, we have differential equations with separate variables m in one side and t in another side. Let us assume it as equation 1. So integrating equation 1 with respect to m and t using these limits. Now we have 3 different limits. So use first 2 limits for k, because k is not known, k is any unknowns. So integrate equation 1 using these 2 limits for the value of k. So once we get k, then use either first and third or second and third for t. Okay. So integrate equation 1 2 times. So first integrations by using first two limits for the value of k. Once we have k, then use either first or third limit for unknown values. t के लिए हमें क्या करना है? First या third use करना है या second या third use करना है. So integrating equation 1 with the limits t from 0 to 50 and m from m0 to 2m0. Here we get integration dm by m from m0 to 2m0 is equal to integration of k times dt, t from 0 to 50. Okay. So from these two limits, here we get k. So what is the integration of 1 upon m with respect to m? Yes, log m. Integration of 1 upon m with respect to m is log m. Limit is from m0 to m0 is equal to k times integration of 1 with respect to t is t only. T is from 0 to 50. So put the upper and lower limit. So log of 2m0 minus log of m0 is equal to 50k. And as we know, log a minus log b. What is log a minus b? Log a upon b. Okay, log 2m0 by m0 is equal to 50k. So k is equal to 1 upon 50 log of 2 only. Equation number. So from first two limits, here we have unknown. K is equal to 1 by 50 log of 2. Now once we have unknown, integrate equation 1 again with respect to same limits or different limits, first and third. Same variable with different limits. So once we have k, integrating equation 1 again with t from 0 to, now either use first and third or second and third. So when we use first and third, then t is from 0 to unknown. Okay, so you just assume it as t1 and m is from m0 to 3m0. We get integration dm by m from m0 to 3m0 is equal to k times. What is k here? We already find the value of k, put it here, 1 by 50 log of 2 into integral 1 with respect to t from 0 to t1. Since t1 is not known. Okay, so integration, this one is log m, it's from m0 to 2m0 is equal to 1 by 50 log 2, integration is t is equal to 0 to t is equal to t1. So this one is again log of 3m0 minus log of m0 is equal to 1 by 50 log 2 into t1. Since t1 minus 0 is only t1. So again use log a minus log b. So it is log 3 1 by 50 log 2 into t1. So what is t1 then? t1 is, so 1 by 50 becomes 50 times log 3 upon log 2. So find log 2 and log 3, multiply it by 50. This gives total number of years when population will. So how many years? 79.25. means approximately 79 years. So how many years will it take? 79 years will it take to triple the populations. This is how we use growth law to find years, or we may find here number of populations also, total quantity of populations when t is given. So example इस तरह का भी हो सकता है, when it will be, or what is the amount of increase in population after 50 years के बाद अभी 50 75 years ले सकते हैं, 80 years ले सकते हैं, and your number of years is always more than previous. जो 50 years में डबल हो रहा है तो आपको ट्रिपल होने के लिए उससे ज्यादा ही टाइम लगेगा, उससे कम नहीं आना चाहिए. Your answer must be greater than 50. तो जो ग्रोथ का होगा, लेकिन डीके में क्या होगा? डीके में कम हो जाएगा. तो क्या हो रहा है? कम होगा डीके. So this is the difference between growth and decay. Getting it? Getting ना? So decay का example ले लेते हैं. Simple example. Only converting into differential में use the limits. Next example. If the rate of growth of bacteria is proportional to the number of growth का ही example है. इसको मत लीजिए, इसको सॉल्व कीजिए. ग्रोथ का एग्जांपल देखिएगा लीजिए. रेडियम decomposes at the rate proportional to the amount present So the radium decomposes at a rate proportional to the amount present. If 5% of the original amount, if 5% of the original amount this appears in 50 years, if 5% of original amount disappears in 50 years, then how much amount remains after 100 years? Then how much amount remains after 100 years? So radium is one of the substance. Okay. So initially it is, again the weight of radium is not known. We don't know what amount is there initially, but 5% of original amount. We don't know the original amount. What is it? But 5% of original amount disappears in 50 years. Disappears means decompose in 50 years. इसमें क्या हो रहा है? Decay. कम हो रहा है. Amount कम हो रहा है. 5% वो कम हो रहा है. अभी क्या find करना है? Find the total amount of radium after 100 years. डिकम्पोज होने के बाद जो भी बचा हुआ है वो अमाउंट हमें फाइंड करना है. So initially if we assume initial amount, okay, we don't know it, so let us assume initially at t is equal to 0, m is equal to m0 again. Initial amount. Okay, you may assume anything. m0 assume करना ऐसा कुछ नहीं. You may assume anything, any amount. Original amount. Radium. Now after 50 years, how many percent disappears? 5%. Original amount is m0. Means your amount disappears 5%. Means m0 minus 5% of m0. So m0 minus 5 by 100 m0. So it is 95 by 100 m0. So after 50 years, it will be 95 by 100 m0. Now find total amount of substance after 30 years. अभी disappears वाला नहीं find करना है. हमें क्या find करना है? Actual amount find करना है जो बचा हुआ है 50-100 years के बाद. disappear होके बचा हुआ है. So find किया. This is the example of decay. So use law of decay. dm by dt, dm by m is equal to minus k times dt. So after separating the variables directly, we variable separable use here directly. So dm by dt is equal to minus km. So dm by m after variable separable, dm by m is equal to minus k dt. So we just assume it as equation 1. Now integrate with respect to m and t using first two limits. Use first two limits for k, and then for unknown m, use first and last limit. So integrating equation 1, with the limits t from 0 to 50 and m from m0 to 95 by 100 m0. We get dm by m from m0 to 95 by 100 m0 is equal to k times integration of 1 with respect to t from 0 to 50. So the integration is log m, so it is minus time, m0 to 95 by 100 m0 is equal to minus k times t is from 0 to 50. Okay. So put upper and lower limit. So after putting upper and lower limit, it is log of 95 m0 by 100 minus log of m0 is equal to minus 50 times k. Okay. So again by using log a minus log b, it is only log 95 by 100 is equal to minus 50k. So from this we get k is equal to minus 1 by 50 log of 95 by 100. So equation 2. Okay. So by using first two limits, here we have unknown k is equal to minus 1 by 50 log of 95 by 100. Now integrating again equation 1, again with the limits m0 to unknown, we don't know the limits, we just assume it as m, and t from 0 to 100. So we get integral m0 to m dm by m is equal to minus k. So minus k, k is already known. By using first two limits we have k. So minus of minus 1 by 50 log of 95 by 100. Minus minus plus. So it is only 1 by 50 log of 95 by 100 into integral dt t from 0 to 100. So it is log m0 to m is 1 by 50 log of